Hi friends, welcome to my another video. Today in this video, I will discuss about the cable size and circuit breaker size calculation for the group of motors. Meaning, I have to calculate the incoming breaker size and the outgoing breaker size for this motor, as well as the incoming cable size and the outgoing cable size calculation for this panel as well as for this motor. The calculation for the breaker size and the cable size for the individual motor is different from the calculation of cable and the breaker size of group of motor. That is why I am covering this topic. In order to better understand the cable size and the circuit breaker size calculation for the group of motors, let us take an example. Here we have 5 motors. One motor is a 35 HP motor, 3 phase. Second motor is 10 HP motor, 3 phase. Third motor is 15 HP motor, 3 phase. Fourth motor is 5 HP motor, 3 phase, but this motor is a standby. And the fifth motor is 3 HP motor, single phase. Our motto in this video will be to calculate this incomer cable size and the incomer breaker size. The second motto will be to calculate the outgoing cable size for different motors and the circuit breaker size for these motors. As per our example, we have 5 different rating motors which I tabulated here. We have to calculate the size of the incoming and outgoing cables and circuit breaker for one NOS of 35 HP 415 volt 3 phase motor at power factor 0.7. The other motor is one NOS 10 HP motor 415 volt 3 phase motor at power factor 0.8. Third motor is one NOS 15 HP 415 volt 3 phase motor at power factor 0.8. The fourth motor is one NOS of 5 HP 415 volt 3 phase motor at power factor 0.8, which is a standby motor. And the last one, which is fifth one NOS of 3 phase 230 volt single phase motor at 0.8 power factor. From the example, it is very clear that we have groups of motor which have different ratings. There is one code, NEC code 430.6A, related to group of motor. According to this code, it is mentioned that it is stated that the feeder which is supplying power supply to all this motor shall have an ampacity not less than 125% of full load current rating of the highest rated motor plus the sum of full load current rating of all the other motors in a group. What does it mean? It means that suppose this motor full load current is X ampere. For this motor it is Y ampere. For this motor it is Z ampere. For this motor it is A ampere, and it is have B ampere. These are the full load current of these motor. And suppose this X is the highest full load current rating among all these ratings. So the code stated that 125% of the highest full load current of the motor plus the sum of other motor full load current, that is Y plus Z plus A plus B, will be the ampacity of the incomer cable. I hope you understood till here. I hope you clearly got the NEC code 430.6A. Now, as in our question, all the motor ratings are given in HP. In order to calculate the full load current, we need the motor rating in watts. So let us convert all the motor rating first in watts. The motor 1 rating is 35 HP 3 phase. Then in order to convert this HP rating into the watt rating, we have to multiply with the 746. This is the conversion factor from HP to watt. So we will get the motor 1 rating in watt as 26 110 watt. In same way, we will convert the motor 2 rating from HP 10 HP to watt, then it will come as 7460 watt. For motor 3, 15 HP is equal to 190 watt. For motor 4, 5 HP is equal to 3730 watt. And for motor 5, which is single phase motor, here I mentioned 3 HP is equal to 2238 watt. So now we got the motor ratings in watts. Now the full load current rating for motor for 3 phase is given as motor rating in watt divided by root 3 into voltage into cos phi. For the single phase, the full load current of the motor is motor rating in watt divided by V into cos phi for single phase. Now we will calculate the full load current for each motors. The full load current for motor 1 is equal to P divided by root 3 into V into cos phi. Motor 1 is a 3-phase motor and the rating of the motor is 26,110, which I mention here, 26,110, and it is a 3-phase motor. So I use 3-phase formula and the motor rating. So the full load current for motor 1 came as 51.9 ampere. In same way, we will calculate the full load current of other motor. So the rating of the motor number 2 is 7460, which I will show you, 7460 for motor 2. And this is also a 3-phase motor. So I use a 3-phase formula to calculate the full load current for motor 2. So it will came as 13 ampere. In same way, for motor 3, it is came as 19.5 ampere. For motor 4, it is came as 6.5 ampere. And for motor 5, which is a single phase motor, motor 5 here is a single phase motor and the motor rating is 2238. So I use here the single phase formula and the motor rating I put as a 2238. So the full load current came as 12.2 ampere. Here you will observe that when I calculated the full load current for motor 5, I use the V value as 230 because it is a single phase motor. So the single phase voltage is 230. But for other motor, which is 3-phase, I use the voltage as 415 volt. And as per the question, the first motor has the power factor 0.7 and all motor has the power factor 0.8. So I use 0.7 for full load current calculation as a power factor for motor 1. Hope you are clear till here. As we got the full load current for each motor, then we can select the outgoing breaker and the cable for particular motor from this ampere rating which we calculated for each motor. So here the full load current for motor 1 is 51.9 ampere, which we calculated here, 51.9 ampere. So the circuit breaker rating is 125% of the full load current of the motor. This 25% is a safety margin. So the calculated value came as 64.8 ampere, but we don't have this rating breaker, so we will go for the next standard available size breaker. So the next standard available size breaker is 80 ampere. I will discuss about the cable later. Now let us check first the breaker rating for each motors. So for the motor 2, the full load current came as 13 ampere, which I shown you here, 13 ampere. So the breaker rating will be 125% of 13 ampere. Then it will be coming as 16.25 ampere. So the breaker rating next available standard breaker size rating is 20 ampere. So we will go for 20 ampere breaker for motor 2. In same way, for motor 3, the full load current rating came as 19.5 ampere, which I will show you here, 19.5 ampere for motor number 3. So the breaker rating will be 125% of 19.5 ampere, which is came as 24.375 ampere. the next standard available size breaker is 25 ampere, so we will select 25 ampere breaker for motor 3. In same way, for motor 4, the full load current rating came as 6.5 ampere, which I will show you here. 6.5 ampere for motor 4, which I mention here. Then the breaker rating is 125% of 6.5, which is came as 8.25 ampere. So the next available breaker rating is 10 ampere. Now the full load current rating for motor 5 is 12.2 ampere, which we calculated here. For motor number 5, the full load motor rating is 12.2 ampere. So the breaker rating will be 125% of 12.2 ampere, which is came as 15.25 ampere. So the next available standard breaker rating is 16 ampere. So we will select 16 ampere breaker for motor 5. Now so far we discussed about the outgoing breaker rating for each motors. Now let us focus to calculate the main breaker rating, which is feeding all this group of motor. As in my beginning of this lecture, I explained about the NEC code 430.6a, and according to this code, the motor which have the maximum full load current rating will be multiplied with 125%, and we will sum up other motor rating, and that will be the main feeder rating. So we will check which motor has the highest rating, full load current rating. We will multiply that full load current with 125%, and then we will sum up other motors full load current rating, and that will be our main feeder breaker rating. If we will compare the full load current rating for each motor, then we will find that the motor 1, which having the full load current rating 51.9, is maximum among all. So we will multiply this current rating, that is 51.9, with 125%, and then we will sum up the resultant rating with other full load current rating of the motors. So 125% of 51.9 came as 64.8, which we can take as a whole 64.9 ampere, and we will sum up with the other motor rating. So 13 ampere, 19.5 ampere and 12.2 ampere. Why I ignored this motor rating? Because it is a standby motor. This will be in the picture when there is another motor breakdown. So we will not take this motor into the consideration for the breaker rating, as well as for the cable rating also. We calculated the cable rating for this particular motor and the cable size for this particular motor, but as a whole for the incomer breaker and for the incomer cable, this motor rating will not come into the picture because it is a standby motor. It will be in the replacement of some other motor. Hope you got. In some of the standard, it can be taken as 10% of the rated current, but as it is a standby motor, we can completely ignore it in calculating the main feeder breaker rating and main cable rating. So I skip this 6.5 ampere. So the total ampere came as 106.9 ampere. So the main breaker rating will be 109.6 ampere, but this size of breaker not available, so we will choose the next standard size available. So the breaker rating is 125 ampere. So far we calculated the outgoing breaker size for the motors as well as the incoming breaker size for this panel. Now we will calculate the cable size for these motors and the main incoming cable size for this panel. Just compare the breaker rating with your local standard and select the cable size. Here I am referring the DY standard, as DY is the local authority here for electricity. Now as we calculated the breaker rating as 80 ampere for motor 1. So the cable size will be, for XLPE cable for 80 ampere is 25 square mm cable. In same way, you can select the cable size depending on the breaker rating from your local standard, local regulation. I will not show you for each of the breaker rating to select the cable size. I will directly jump for the main incomer breaker size, that is 125 ampere, and accordingly I will select the cable size from our local regulation. In my case it is DIVA regulation. So our calculated breaker rating is 125 ampere. So our cable will be 50 square mm cable, multi-core XLPE type. So the final incomer cable size is 4 core 50 square mm XLPE cable, and as we know that the ECC cable will be half of the phase cable after 35 square mm. So it is 50 square mm, so ECC cable will be 25 square mm. I hope you got the concept how to calculate the cable size and circuit breaker size for group of motors. If you really like this video, then please subscribe to my channel and give thumbs up. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.